Namaste everyone. Let us see Fourier transform of triangular signals. If I have a triangular signal which is not periodic, which is only of a finite duration, so I am taking one triangular triangular signal like this, which is situated at origin and it is of 2t horizontal width and unit amplitude. So we will try to calculate Fourier transform of a signal like this, which is having unit amplitude and 2t horizontal width. Let us see and let us try to calculate the Fourier transform. You can see the question and you can try the Fourier transform by yourself. If you are not able to get, you can continue the video. In this video, I will be discussing the solution of this particular problem. So first of all, we have to write it the function in terms of the elementary signals. Elementary signals are the unit impulse, unit step, or unit ramp. So it is having a slope, it is a slopey signal, so I will be writing this signal in terms of unit ramp signal. So for writing a signal in terms of unit ramp, we need to know the slope of the signal. The slope of this signal, what is the slope of this signal? Slope is calculated by y2 minus y1 upon x2 minus x1. So y2 is 1 minus 0 upon x2 is 0 minus t, so 0 plus t, so this is slope is 1 upon t. Slope of this signal is 1 upon t. Now in terms of ramp function, this will be 1 upon t into rt plus t. So this will be 1 upon t into rt plus t, means rt starting from minus t, so that is rt plus t. This signal will be going towards infinity from starting from minus t. It will go towards infinity in time. But if I want to stop it at 0, I have to subtract a signal of equal slope, equal negative slope originated at the origin. So I am subtracting minus 1 upon t rt. Okay. Now there is one more signal right side here, which is again going down. So I have to again subtract minus 1 upon t rt. And then I have to stop this here. Then I have to add plus 1 upon t rt minus t. Okay. So in this way, the total signal, the complete this signal can be represented by 1 upon t rt plus t minus 2 upon t rt plus 1 upon t rt plus t. So 2 upon t rt from with this one, and from this one this becomes 2. Okay. So total the signal can be represented by this. Now we don't know the Fourier transform of ramp. So what can be done? What can we do? We have to think. We have to think about the property. If I differentiate this signal, then it will become its RT will be converted to unit step. If I differentiate again, it will be converted to the ramp and the delta signal, the impulse signal, and we properly know, we well know the Fourier transform of impulse signal. Therefore, it will be better to go by this differentiation process. So first of all, if I do differentiation first time, then it will be converted to unit step. This one, and if I do differentiation again second time, differentiation with respect to t again, so then it will be 1 upon t, this is a multiply, and unit step will be converted to delta t at all three places. Now taking Fourier transform both sides, taking Fourier transform both sides, then this will be j omega whole square, because for one differentiation j omega is multiplied. For second order, j omega square is multiplied to x of j omega. So x of j omega will be multiplied by j omega whole square. Okay. Now here it is shifting of delta t. The Fourier transform of delta t is 1, and now here it is shifted by capital T. Therefore, e to the power j omega t will be multiplied to this. Okay. Now minus 2 upon t, the Fourier transform of delta t 1, and this is shifted by minus t, so e to the power minus j omega t into 1. Okay. So I am taking this dc term first, then taking 2 by t common from the remaining two terms, then this can be written as e to the power j omega t, e to the power minus j omega t divided by 2. This is cos j omega t. So 2 upon t, the Fourier transform is j omega square x of j omega is minus 2 upon t, 1 minus cos j omega t. Your cos or cos omega, 1 minus cos omega t. Sorry, cos omega. Okay, no problem. And cos omega t can be written as 1 minus 2 sin omega square t. Okay, and 1 and 1 cancel, so therefore this will be, this is minus square, minus is also cancel, so omega square x of j omega equal to 2 upon t, 2 sin omega square t. So 2 and 2 becomes 4 upon t, sin square omega t by 2 divided by omega t by 2 into omega t by 2 whole square. So omega square x of j omega square equal to 4 omega square t squared divided by 4t sin c square omega t by 2, or omega square x of j omega equal to 4 omega square equal to t sin square omega t by 2. Sin c square, and the spectrum of sinc function is like this, which have time period t. Okay, so this is how the Fourier transform of a triangular signal can be obtained. Okay, thank you for watching, thank you for attending watching this video.